A shell in hacker's hands is a remote control for your entire system. A shell is a software that lets a user talk to an operating system, in other words, offering a command line interface. In cybersecurity, it is the interactive session attackers use after they have broken in. Once an attacker has a shell, they can run commands as if they were sitting at the machine. That single access point enables a chain of dangerous actions. Think of remote control, privilege escalation, data theft, persistence, pivoting. Now, remote system control, when it comes to remote system control, attackers execute programs or scripts on the machine from anywhere. Think launching reconnaissance and installing tools or running ransomware. Now, when it comes to privilege escalation, an attacker with a restricted shell hunts for ways to gain admin rights. Once they succeed, well, everything becomes possible. With shell access, they can reach, read, and copy sensitive files off your system, customer data, keys, intellectual property, and after access, attackers often plant backdoors or hidden accounts so they can come back later even if you patch the initial vulnerability. And of course, we do not forget that attackers, through post-exploitation, they can deploy malware, delete logs, create stealthy users, and of course, they can do network pivoting. They use one compromised machine as a springboard to reach others inside your network. Today, we're going to discuss shells, and we're going to talk about all types of shells. And of course, as a practical scenario, we will go over shells overview from TryHackMe. Let's get started. Let's start with one of the most popular shells, which is reverse shell. The reverse shell is sometimes called a connect back shell because it allows the attacker to execute system commands on the victim machine by first making the victim connect back to the attacker machine. That's why it's called connect back machine. It's what used widely in cyber attacks. Here's an example, or here's a popular example of a reverse shell. So we have this command here. As you can see, it consists of several commands piped together using the pipe. So the first command we have rm/temp/f. This command deletes any existing named pipe, right? Because named pipe are essentials for establishing bidirectional connections between machines. Any existing named pipes could create conflicts with any future named pipes that we wish to create. So removing any existing named pipes ensures smooth connections or smooth bidirectional connections. Next, we have make directory first input, first output, /temp/f. Here we create a new name pipe and we store it in /temp/f. This is a location that you can change, by the way. And then we use cat /temp/f and we pipe it to a bash shell or a bash command. So what this command does here is it reads the contents of the named pipe, okay, and then passes the output of the named pipe into the bash shell command, which allows the attacker to execute system commands directly. Now, after the attacker has established a bash shell, it now redirects or pipes the output to the existing connection. This command connects to the victim machine, right? And then it redirects the command output back to the named pipe. So now, how to implement a reverse shell? So basically, you need two components. First, you need an access to the victim machine, and you need your attacker machine. On your attacker machine, you have to act as the listener, because as I said earlier, it is a connect back machine. So the victim has to connect to your machine. So first, we create a listener on the attacker machine using this command, nc-lvp, and we choose the preferred port. So let's say 4546. And now the attacker machine listens on the incoming connections. Now we come to the fun part. Here is the victim machine. So in the victim machine, we assume that we have compromised the victim machine through various methods, such as maybe exploiting our application vulnerability or a zero-day. And then after having access to the machine, we want to connect back to the attacker machine. Sometimes this reverse shell is implemented pre-compromised. That's why I name it pre-compromised here, because sometimes you actually execute this through an interface in a web application, in a vulnerable application through command injection, SQL injection. You execute this reverse shell, and on your attacker machine, you will receive a connection, having, of course, established the listener already. So we go back here and we copy this. We paste it. Of course, that's not the full story here. We're going to have to change the port. The port here has to be the port that you have selected when you create the listener. So 4546 in my case. And so 4546, right. And we have to change the IP address. Since I don't know the IP address of my machine, I'm going to have to use ifconfig to find the IP address. So this is the IP address of my machine. It is the IP address that is bound to the active networking interface. Here we have many network interfaces. The ones that's active here is the ENC5. So we're going to have to copy the IP address here. This is the IP address of the attacker machine. And then we paste it right here. Then we go back and we re-execute the listener. Okay, now the victim machine is connecting to the attacker machine. As you can see, connection received on 10.10.165.243, which is the IP address of the victim, by the way. Now, through the reverse shell, I can execute system commands. You see, ID, and now it gives me the ID of the user. That's not the ID of the user on the attacker machine. It's the ID of the user on the victim machine. You see now, instead of directly or physically executing commands on the victim machine, I can now execute the commands remotely from the attacker machine using the reverse shell. That's how reverse shell works. Now let's answer some questions here. So what type of a shell allows an attacker to execute commands remotely after the target connects back? It is reverse shell. What tool is commonly used to set up a listener for a reverse shell? It is the Netcat tool that we already used. Now let's talk about the other type of shells, which is the bind shell. Bind shell is less popular than reverse shell. Well, because it needs to be maintained and it needs to stay active on the attacker's machine. So why it's called bind? Because it exposes a port on the victim machine and requires that this port is open to receive communications. So in this example, in the bind shell, the victim machine will not connect to the attacker machine. It will listen for the incoming connection. It will act as the listener. On the other hand, the attacker's machine will act as the machine that initiates the connection. It's the place where we will execute the command that will connect to the victim machine. So in this case, the attacker connects to the victim machine, not the other way around. And basically, it is useful when the victim machine is behind firewall that restricts outgoing connections. Okay. So an example of a bind shell is actually this one. Take a look at this one. This one is more complex than the previous one. So I will explain this example first, then I will pivot to the first example. So the same logic follows here. First, we remove any existing name pipes to allow for clean named pipes connections, and then we create a new named pipe, and then we open the new named pipe and pipe the output of the named pipe into a new bash shell that allows us to execute system commands. Here we redirect standard input to standard output error, and so that we can detect any errors that may arise. And then we pipe the shell that we opened using bash into a netcat session. You see, the netcat session here uses the -L option. The -L here runs netcat in a listening mode or in the listener mode, which means now the machine that executes this command will act as the listener, which listens on port 8080 for incoming connections. So now, if we come back to the logic of the bind shell, the attacker machine will act as the machine that initiates the connection. This command now, or based on that logic, this command will be executed now on the victim machine to listen for the incoming connections. In reverse shells, the attacker machine was listening. Now the victim machine will listen for the incoming connection. So we copy this and we go back to the victim machine. We paste this, and now the victim machine is in the listener mode. It listens for incoming connections on port 8080. So now, whatever command I use now to connect back with the victim machine should be based on the port 8080. Using Netcat now, okay, here -N, as stated, it disables DNS resolution for faster connections, and V for verbose mode to see the connection or what's happening in the terminal. So NC-NV, and we need the IP address of the victim machine, which can be found here, and then the port 8080. You see now it's not a connect back shell. The attacker is actively seeking the connection to the victim machine. So connection to port 8080 succeeded, and you see now the prompt changed from root to Ubuntu. Now we are actively executing system commands through the bash shell on the victim machine. So now if we issue the ID command, you see it is indicating the user on the victim machine. Oops, okay. So that's the bind shell. Okay, let's answer some questions. So what type of shell opens a specific port on the target for incoming connections on the port from the attacker? It is blind shell. Listening below which port number requires root access or privileged permissions. So here it is 1024, and this means that if you choose port that's less than 1024 in your listener, you require, or it will require you root access. That's why if you compromise a machine, or if you're part of pen testing, and you got access to user below root, it is recommended to use a port above 1024 for any listener or shell you want to establish. Now let's get back to the reverse shell because it's more popular than the bind shells. So we know that the reverse shell is executed exclusively on the victim machine so that it connects back to the attacker machine through netcat. And we learned that on the attacker machine, we have to execute a netcat listener here so that we receive the connection. However, sometimes we need more stability in the connection. So here, if we come back now to the reverse shell, copy it, and we execute on the victim machine. Before we do that, we're going to have to use a listener. One of the popular ways to use an established or maybe a more stable listener is to use rlwrap. This wraps the connection or netcat connection in rlwrap and allows you to have more stable shell and to execute commands such as history commands or maybe to use the arrow keys. So rlwrap C -lvp 4546. Now we have a listener running on the attacker's machine. We go to the victim machine, paste the reverse shell, make sure the IP address matches the correct one. So we copy the IP address from here and we paste it in the appropriate place. Well, we have done some wrong things. Gonna have to paste the command again. Okay, we hit connect. Let's check. Oh, so it's 4546. So fix the port. Now the victim is establishing connection to my machine and connection received. So if we execute now, who am I? It is the Ubuntu. Okay, let's terminate the connection and get back. Another way to run a stable listener is to use the tool named socat. So socat allows you also to establish a listener and also to connect or to do some reverse shell. That's why there's something called as the socat reverse shell. So in socat, you can create listeners and you can also connect to these listeners. Now on the victim machine, since there is no socat running, I'm going to have to use socat as only the listener. Okay. So if we copy one of these commands and execute this command on the attacker machine, you see the port here is 443. Okay. And now it's using TCP protocol to listen. Execute this. Now we're using socat to receive connections. Back to the victim machine, you can execute the same reverse shell. However, you're going to have to change the port because now, well, the port has changed. Connect, and we receive, you see, the connection. Why? It is the Ubuntu user. All right, answering some questions. Which flexible networking tool allows you to create a socket connection between two data sources? It is the rlwrap. Wait, which is, it's a socket connection, so it's socat. Next, we have which command line utility provides read line style editing and command history for programs that like it, enhancing the interaction with the shell listener. Well, now it is the rlwrap. And what is the improved version of Netcat distributed with the Nmap project that offers additional features like SSL support for listening to encrypted shells? Well, I skipped this. It is the Ncat and can be found here. Ncat can also be used to create listeners and to use the SSL option so that you encrypt the connection between you and the victim, or maybe between you and the machine you're managing, because you can also use Netcat to do system administration like you do through SSH. But with --SSL, you can encrypt the entire connection. Since reverse shells are more popular than bound shells, there are other ways to establish reverse shells in other programming languages. For example, you can use PHP shells or use PHP reverse shells. This one, for example, uses the system function in PHP to connect back to the attacker machine using bash and redirects standard input and output and errors to the attacker. And you can also use PHP reverse shells, however, using different functions. This one uses system function. This one uses shell exec. But this one, you see, it's a one-liner, and that's specifically executed in the browser, not on the victim's terminal. Because you see, it requires you to add the CMD query parameter. When this is executed in the browser, it allows you to execute system commands through the query parameter CMD. Well, that's out of the scope of this video, but it is worth mentioning. Another one is this one. You see, this one uses the connects to the attacker machine using a socket. So by creating a socket, it connects to the attacker machine on port 443, and of course, standard output and errors are redirected to the attacker machine. And also, we can use Python. Python also used or can be used to establish reverse shells. You see, this one, for example, uses the sub-process module in Python to create a connection to the attacker's machine by creating a socket. You can find examples of these in the room, by the way. So here are several examples that can be used to create a reverse shell. You see, some of them are in PHP, some of them are in Python, and they use built-in system functions or functions within the programming language itself to establish the reverse shells, as we illustrated earlier. So now, which Python module is commonly used for managing shell commands and establishing reverse shell connections in security assessments? It is the sub-process. And you see, you can see an active example here. This one. So this one uses the sub-process module to spawn a shell and redirect it back to the attacker's machine. What shell payload method in a common scripting language uses the exec, shell exec, system, pass-through, and popen functions to execute commands remotely through a TCP connection? Well, you see, system and shell exec are PHP functions. That's why the programming language here is PHP. And which scripting language can use a reverse shell by exporting environment variables and creating a socket connection? So this one here is Python. All right, let's try them out. So maybe we can try the Python one. And of course, do not forget, these are reverse shells, meaning they are first executed on the victim machine. It's going to terminate the current connection here. Clear if config. So we paste this, but before executing, let's go back to the attacker machine and maybe have the listener ready. So rlwrap nc-nv 454. Add the port. So now we're listening on port 4556 back to the victim machine. So here we have to change two variables. You see, this one exports the environment variables, namely we have our host and we have our port. These represent the connection parameters that or of the attacker machine. So here 4546 are for the port, and for the IP, again, we're going to have to take a look at the IP and change it. Let's try. Command not found. Yeah, that's because let's fix this. Maybe Python is not installed on the victim machine. We didn't verify this. So let's see now. So connection received. So it worked. And now you see the prompt changed from root to Ubuntu. So there are several methods to achieve reverse shell even using scripting programming languages. Now let's talk about web shells. Well, a web shell works similar to reverse shell. However, the difference is web shell is uploaded to the web server or the compromised website. Before we compromise the website, you upload the web shell to test if the website accepts and executes this web shell. Usually, web shells are exploited through vulnerabilities such as unrestricted file upload or directory traversal, or maybe even command injection. When a web shell is uploaded to the web server, it allows you to execute system commands on the victim's machine. From there, you can also execute reverse shell and have a full connection back to your machine. An example of web shell is this one. You see, in this web shell, it's a code written in PHP and can be saved as a file. Maybe you name it backdoor.php. You see, this web shell uses the cmd query parameter to allow you to execute system commands. Through this query parameter, you will execute system commands on the underlying host of the victim machine. When you save this file, okay, and upload it to the web server of the victim machine, in the browser, you will send a GET request, maybe through a tool like curl, okay, and you will assume that the victim's web server IP is this one, okay, and the shell name is cmd.php. And using -d, we specify a query parameter. In our case, it is the cmd. The cmd here is specified, and we specify a value for the cmd. Here, the value is, as you can see, a bash reverse shell. A reverse shell written in bash allows us to connect to the attacker machine that's listening on the specified port. You see, through PHP shell or a web shell, we can execute a reverse shell. Of course, you can specify the command you want to execute through the cmd or the query parameter. This is sent through a GET request. We will see an active example. Now, in the task, there are two questions, and there is another example laid down in the task here, another example of a classic web shell. This one is much simpler and is actually used by sending a GET request. So when you save this into a file, say named webshell.php, you will send this as part of a GET request. And your URL will look like this one. This is the URL. You see, victim.com/uploads/shell.php. This is your shell. And of course, the query parameter should be specified. Here, the command we wish to execute is who am I. If the output of this command is the user of the victim machine, we know that the web server has processed and executed the web shell successfully. Of course, you do not need to write these web shells yourself because there are many online web shells that you can use and upload directly to the victim's website. So web vulnerability type allows attackers to upload a malicious script by failing to restrict file types. It is unrestricted file uploads. And what is a malicious script uploaded to a vulnerable application to gain unauthorized access? Well, it is the subject of this video, this web shell. Okay, task 8, we have a practical task where we will use the knowledge we have learned and apply it on a vulnerable machine. You see, we have three pages here. First one represents the landing page. Next, we have a page that's vulnerable to command injection and a page that's vulnerable to unrestricted file upload. However, we're not going to be able to do this. Why? Because I tried to access these URLs in the attacker's box and they are not working. Hopefully, someone from the TryHackMe staff could see this video because I couldn't find a button to report this error. The machine is running. However, I cannot access the page from the attacker box. Therefore, we're not going to be able to do this practical task. To verify my theory, I scanned the victim machine for open ports. You see, I found only 2 ports open, 22 and 80. And these ports are not open, which means they cannot be accessed. Hopefully someone from the TryHackMe staff could see this and maybe fix it. Now, to see a real example of how reverse shells are applied, so take a look at this video. You can find the link in the video description where you will see an example of how reverse shells are, or maybe shells in general, are applied in a practical real scenario.